Okay, so today we're going to be looking at quadratics. Now, you've come across quadratics. You will have come across quadratics at GCSE, and the first part of this is no different from GCSE, except for how you use it to model. So what I mean by that is, let's start off with the basics. What is a quadratic? So a quadratic is something, so an equation of the form ax squared plus bx plus c. So we're going to be looking at quadratics, and quadratics are of that form. Now in A level and in GCSE, the key skill that you're going to have is to complete the square. Complete the square helps you to sketch it. So we solve quadratics in exactly the same way. The difference is you don't have a non-calculator paper. Everything is calculator. Now on your class whiz calculator, which is the calculator you should all be using, there's a function where you can type in the A, the B, and the C, and it will give you your roots. So it will complete the square or factorize it for you. You can work backwards to factorize for you, but it will solve the equation for you. This doesn't always help you because sometimes there's letters involved, but a key skill, like we did when we did proofs, is to complete the square. So let's practice a few of those and just double check you're still happy with it. So if we take 2x squared plus 12x plus 7, and when we complete the square, remember we want it in the form ax plus b squared plus c, if it's a positive x squared, and we want it on the form a minus b x plus c squared, if it's a negative x squared. So the first step here is I'm going to take 2 outside the bracket, and I'm going to get x squared plus 6x plus 7. And then the easier bit to complete the square for is that bit in the middle. It doesn't matter how you do it. You might do a big double bracket. I tend to just do a line down, complete this bit here, which is x plus 3 all squared minus 9, and then multiply the whole thing by 2. So just a quick reminder, completing the square, you're taking what's in front of the x and you're halving it. And then you're taking this number and you're squaring it. And that's where you get what you take away. So this is that number squared. Now the whole of that little bit there has to be multiplied by 2. So we end up with 2x plus 3 squared minus 18 plus 7. And so we have 2x plus 3 squared minus 11. Okay, so that's a reminder of how to complete the square. Now let's have a look if we have a negative x squared involved. So let's take 20x minus 5x squared plus 3. Remember, if there's a negative, we're going to end up with something in this form. So I think it's always easier to put the x squared first, because that's how we're used to seeing things. So I'm going to rearrange that, put the x squared first, then the x, sorry, then the 3. And I'm going to take the negative outside of the bracket. So I'm going to have minus 5 outside. So I end up with x squared. Remember, we know how to complete the square if it's just x squared. And then that's going to give you minus 4x plus 3, because when you open that out, your minus and a minus become a plus. I'm going to take this bit here and complete the square. And then the whole of that bit has to be multiplied by minus 5. So we end up with minus 5, lots of x minus 2 squared, minus 5 times minus 4 to give me plus 20, plus 3. And then if I'm going to write it in that form, I've got 20 and 3 to give me 23 minus 5, x minus 2 squared. So that's a reminder for completing the square. Now, once we've completed the square, there's lots of things we can do with that. We can find out the minimum points, the maximum points, we can sketch it, and that's what we're going to use it for. So in your A-level exams, you'll be asked to sketch quadratic curves. They don't need to be beautiful. I mean, some teachers will make you use, they're not accurate, they're sketches. So some teachers will make you use a ruler or whatever, but at the end of the day, in an exam, it doesn't matter. You know, So you want to sketch. Doesn't even really need to be scale as long as you've labeled it correctly. So if I have my quadratic here, so this is a positive x squared, it's my smiley face. What are all these bits called? Where it crosses the axes here, these pink bits are called my roots. So this is the point at which y equals 0. So this is when you solve a quadratic, the answers you get. This bit here is your y-intercept. So it's essentially your plus c. You get this point here, which is a minimum point. And when you have completed the square form, so when you have something in that form where you've got x plus b squared plus c, this minimum point is minus b, c. So the y coordinate is whatever is afterwards, and whatever makes that bracket here equals 0 is your x coordinate of your minimum point. So those are all the features that you need. So in order, if we're able to complete the square, then what happens is it becomes really easy to find each and every one of these points. So let's take a graph which we're going to use. So let's take y equals, let's take something straightforward. X squared, let's take plus 3x minus 4. So I want to sketch that. Now, hopefully you think about it, I want my roots. My roots are when y is 0. Now, if you can see it, you can see that factorizes quite nicely. We get 4 and we get 1. We get plus 4 minus 1, and we can say that equals 0. So that's where it crosses the axes. So it crosses when x is 1 and x is minus 4. We can see that our plus c is minus 4. And if we complete the square, we'll be able to find our turning point. We half what's in front of the x. So we're going to half this 3. So when we half the 3, we get 3 over 2. And that's all squared. Then we minus squaring that. 3 over 2 squared, square the top, square the bottom. We get 9 over 4 minus 4. And then you get x plus 3 over 2 squared, and that's going to give you minus 25 over 4. So we now know that our minimum point, because it's a positive x squared, is minus 3 over 2, because that's what makes this bracket equal 0, and what's left over, which is minus 25 over 4. So now we can sketch the entire thing. And like I said, it, can try to do it a little bit to scale, but it doesn't need to be beautiful. This is exactly how we would do it. Minus 4 minus 1. You might want to minus 3 over 2. You might want to double check. Minus 25 over 4, is whether it's above or below minus 4. So this is minus 4, which is your turning point. So let's say that's your point, your minimum point. And I will attempt. Minus 4 should be above, ignore me. Minus 4 should be there, and I will attempt to draw it. And that minimum point there is minus 3 over 2 minus 25 over 4. And that could be a 3 or 4 mark question where you've sketched your whole graph. Where did I get minus 25 over 4 from? Okay, so minus 9 over 4 minus 4. So 4 is the same as 16 over 4 minus 9. So minus 9 minus 16 is going to give you minus 25. You can also use your calculators. So if you have your calculators in front of you, I cannot see where I put mine at the moment. But if you go into the equation button, and then if you solve it, and if you keep scrolling, it will also give you your minimum point. So you can always use that to check. But if it says show all your working, they want to see that you've done all of this. Okay, now I've done this before when we did proofs, but we're also going to use completing the square to prove the quadratic formula. So we're going to work through that. So if we know ax squared plus bx plus c equals 0, we want to prove that x equals minus b plus or minus the square root of b squared minus 4ac over 2a, which is a formula that you know. So we're going to use exactly the same method, but because it equals 0, in order to complete the square, we want to end up with just x squared. So my first step is I'm going to divide through by a. I'm going to divide everything by a. When I do that, I get x squared plus b over ax plus c over a equals 0. Now we've got it in the form which we know how to complete the square for. So we're going to half what's in front of the x. So we've got b over a in front of the x. When we half that, we're going to get a half, which is b over 2a, because the half goes on the bottom, squared. Now what we're going to do is square this term over here. Square the top to give us b squared, square the bottom, which gives us 4a squared. And we still have our c over a equals 0. Now I'm going to move everything that's not squared onto the right-hand side. So I get x plus b over 2a squared equals, I move this minus, I move the minus b squared over 4a squared, it becomes plus. So b squared over 4a squared minus, and the c over a becomes minus. Now what I can do is make that into one fraction. So I'm going to put the whole thing over 4a squared. When I do that, the b squared stays the same, but the c needs to be multiplied by an additional 4 and an additional a. And hopefully you can see it's starting to look like what it needs to. Now I'm going to take the square root of both sides, which leaves me with x plus b over 2a. This plus and minus the square root of that top bit. When I take the square root of the bottom, the square root of 4 is 2, and the square root of a squared is a. Sorry. And then x is therefore, bring the b over 2a to the other side, plus minus 4ac over 2a. Because the denominator is the same, I can put that all together, and I end up with my quadratic formula. So I know we looked at this briefly when we looked at proofs, but it's quite nice to see again when we're talking about completing the square. Okay, so now the next bit of information, which you may or may not have come across, but is new if you like to A-level, is the concept of a discriminant. Now what a discriminant is, and some people will recognize that, and it's sometimes represented by a triangle. So the discriminant is part of, and I've probably spelled that wrong, let's spell that again for you actually. D-I-S-C-R-I, you can tell I'm a mathematician and a physicist. I don't do words so well. Happy to talk them, I'm not very good at spelling. Anyway, a discriminant. The discriminant is this bit, is b squared minus 4ac. So remember a quadratic, the bit in front of the x squared, a squared plus bx plus c, we represent, and the discriminant is when it equals 0. Okay, so we have a quadratic. The discriminant is this bit of the quadratic formula. It's b squared minus 4ac. And when we work just that bit out, it tells us a few things. If it's bigger than 0, we say it has 2 distinct roots. That means it's a graph that looks, if it's a positive, it looks like that. It crosses at 2 points. If b squared minus 4ac equals 0, we say it has equal roots. It means it just sort of sits somewhere like that. So it could be something like x minus 2 all squared, where this therefore would be 2. Okay, so the roots are equal. And if b squared minus 4ac is less than 0, it has no roots. So it sits up there, You know, if it was negative, it could sit down there. So it has what we call no real roots. Now, if you do further maths, you'll talk about complex roots. So that's why we talk about things having no real roots. So those are the discriminants. So it's not that we call them equal roots. We don't really call them one root because it's still two, you could write it as two brackets. So the kind of questions you would get involving a discriminant, if I take a past paper question, it would say something like this. So x squared plus 2px plus 3p plus 4 equals 0. And you get told p is a positive constant. And the equation has equal roots. And it says, find the value of p. Okay, so that's from an AS exam paper. So you look at that, you know it's got equal roots. The minute you see that, your brain's going to go discriminant equals 0. So we know that b squared minus 4ac equals 0. And we go, okay, so let's identify each of those things. So we've got a is 1, b is 2p, and c is 3p plus 4. So if we were going to work out b squared minus 4ac, we're going to have 2p, and this is the important thing, all squared. So the 2 is squared, and so is the p, minus 4 lots of a and c. And we know that's going to be 0. We know that's going to equal 0. So we're going to get 4p squared minus 4 times 3, so it's going to give you minus 12p minus 16 equals 0. I can divide through by 4. I can factorize, get p plus 1, p minus 4, and I can get p equals minus 1 or p equals 4. But in the question, it tells me it has to be a positive constant. So we'd say p equals 4, and that would be your answer. If you wrote minus 1 and 4, as long as you then crossed out the minus 1 or wrote not valid, has to be positive, you'd get all the marks, but you would lose a mark if you left it in there. So that's the kind of problem you could have involving a discriminant. So now let's have a look at how it gets trickier and what problems we could have in terms of modeling quadratics. So if I pull up a past paper question, which hopefully you guys can see. Right, so, okay. Right, we have, I know you can see that, there you go. So a suspension bridge cable, PQR, hangs between 2 vertical towers. Lots of information there. It tells you the towers are 100 meters apart and each tower is 24 meters high, okay? It tells you, it shows it's a symmetrical quadratic. So in the question, they're telling you you've got a symmetric quadratic curve. And they're asking you to find the equation. Now I'm looking at that, and straight away what I can see is it's a positive quadratic. I always think looking at it in terms of a completed the square form is easier, because what can I see? I can see from here, I can see my minimum point. So my minimum point is at x equals 0, y equals 4. And then I also have a point, if that's symmetrical, that must be 50 and that must be minus 50 if we're looking at an axis. And I also know I have points at 50, 24, and minus 50, 24. So let's see what we know. Positive quadratic, so my brain is first going to write y equals ax plus b squared plus c. But we know the c is going to be 4, because that's how I find my minimum point. And I know that b is going to be 0. So we know it's going to be y equals ax squared, because the b is 0, because it goes through the origin in this case, plus 4. And now we've made it easy because we've only got one unknown. And we could use either of those 2 points. So say I use the 50. I'm going to have 50 equals a times 24 squared plus, sorry, wrong way round. My y coordinate is 24. Let's do that again. 24 equals a times 50 squared plus 4. So I'm going to get 50 squared times a equals 20. So a is going to be 20 over 50 squared. Right. So when you put that in your calculator, you should get 1 over 125, I think. But this time in the morning, I don't trust my mental arithmetic. So you've got 20 over 50 squared, and you get 1 over 125. So your final answer for this question, for part A, your equation would be, if I write it on this side, y equals 1 over 125 x squared plus 4. And you have got, and you've completed that first part of an A-level question. Part B tells you, Lee can safely inspect the cable up to a height of 12 meters. Okay. A defect is reported on the cable at location 19 meters horizontally from one of the towers. So 19 meters horizontally would be here, I guess, where this space is 19, right? So it's from the tower, that's the important bit. So if the space is 19, that means the coordinate, so if I say this space is 19, is the coordinate here must be 31. So you could substitute that in and you would see whether it was higher or lower than 12 and whether it would be safe. But that's the kind of modeling question that you get around quadratics, right? So that's one type. The other type of question you can get, that's actually from an A-level paper, but obviously it's AS material. So the other type of question you can get, I had this paper clearly open for a reason. Let's try to find the question. Okay. Apologies. Okay, Laurie. All right, here we go. So you've got a negative quadratic here, and you're told this represents a company makes a particular type of children's toy. The annual profit is modeled by this equation, okay, where P is the profit, and this is something lots of students miss in the exam. It's measured in thousands of pounds, okay, so you have to be careful of that. And X is measured in pounds. Then it says, explain why 15 is not a sensible selling price for the toy. Okay, so the selling price is the X. You would substitute that in. 100 minus 6.25, 15 minus 9 squared, and you find it gives you a negative number. So you say it's not a sensible selling price for the toy because it gives you negative profit or a loss, and a company does not want to be making a loss. Then it says, find according to the model. So then it asks you to solve making it equal to 80,000. You've got to make sure you realize that's making it equal to 80. You open it all up and you solve the quadratic. That's not the bit that we're interested in. The bit we're interested in here is where further on it tells you, state the maximum possible annual profit and the selling price that maximizes it. Now, because it's already in this completed the square form, we can instantly see the maximum point. So the same way the minimum point is given, the maximum point. So if we look at this, we say, what makes this bracket 0? That would be when X equals 9. So the maximum selling price that maximizes the profit would be £9. And what's my plus C? My plus C is 100. Not my plus C, like in terms of, not my plus C in terms of my, just to make that super clear, my y-intercept, but in terms of the value outside of the completed the square form, it's 100 here. The 6.25 is not relevant here. But remember, it's in thousands of pounds. So my maximum profit is therefore £100,000. So if you've already done this, you'll have done this. This would have been about chapter 2 in AS. If you're currently in year 11, going to go into year 12, this is quite a good topic to start off on, and a transition-y sort of topic, because there's nothing really new from GCSE, maybe some of the discriminant stuff, but how we then think about it and relate it to real life problems is the bit that makes it real. So I've got a few modeling quadratic problems. I can upload those somewhere. And if you've got any questions, let me know. And good luck with everything. So for those of you doing GCSE or in year 10 at 12:30 today, I'll be continuing with the chemistry and we'll be doing exam questions. And at 3:30, we'll look at maths. For A level, I'm still trying to work out the best way to do it, but I will be doing some transition stuff for chemistry, physics, and more stuff on maths.